We had a request to predict the products, which is a part 2 question. We did the fall 21 this morning, and during that video, it was mentioned that occasionally on tests, this shows up randomly. It just showed up randomly in our review. Draw hots. It may show up on your test. So we're going to start there. It is a strong acid that has the same behavior as sulfuric acid. It looks a lot like sulfuric acid. In fact, you're going to get partial credit if you just drew sulfuric acid. Show all pi bonds. So you're not allowed short forms like SO3. It's the same as sulfuric acid up to this point. And then there's an organic piece on it. It's a phenyl that has another group on it. So if I told you that, you should be able to get 0.75 out of 1, unless it's 2 points. Phenyl, if you drew just this, you get like most credit. Now, if I told you on the phenyl, there's a methyl as far away from that group as possible, right? Then you would put it there. And where's that sign up sheet? You got it. I got it. And you're gonna write down the line. And I just put you're gonna put your last name. This is our activity. So they're gonna get 5. You're getting 3 or 4. I don't know. So there's hot. Be ready for it on any test, okay?
Is that it? You just write that?
Just draw that, yeah. And now we can start. You don't need hots for this one at all because its job is what in this reaction? If it's serving the role of sulfuric acid, what's its job? Starts with a C, makes noises like a feline. Okay, that's it. Catalyst. Catalysts don't show up in the product. Please don't draw anything to do with hots in this box. It's the catalyst. It makes the reaction speed up, but it doesn't get used up. All right, so here we go. Getting a little room here. The minor product would be the one where the Cl ends up on the less substituted carbon, which is here. And where'd the H go? Oh, wow. I got my fat eraser on still. There we go. Where's the H? I drew it already. It's in the product. Where is it? Where is the new H? You can give me a number and a degree sign and we can move on. Tertiary? Yes. I'm going to draw it and erase it because you don't need to show me H's. There. Okay. Major has the cation on the tertiary, which leads to the Cl being on the tertiary. I don't want cations on here. Every semester, students draw me the cations instead of the products. That's not what this is about. Final products, please. Now, you want to watch this morning's video because there was 2 rearrangement products for the first reaction there. Yeah, I think this morning's was a little closer to yours. I'm just saying it. This has got all the elements, and the rearrangements come up down here, so it's just as good. So always draw the products that are the direct result of Cl going on each of the carbons of the alkene. There's 2 products for you, free of charge. Copy the carbons, put the Cl on one of the carbons in one, and the other carbon in the other, and you got 2 points.
How do you not have major?
Because it comes from a tertiary carbocation, which has more hyperconjugation than a secondary carbocation, which means it's easier to make, which means it'll form faster. That's why.
So could you put the Cl for the minor on any of the other?
No, there will not be a reaction away from the 2 alkene carbons because already one of them was tertiary, which is as stable as you can get. You're not even thinking about rearrangements when you're directly going to a tertiary carbocation, unless it's in a square, right? Then you will rearrange it. Okay, squares are bad. Thinking and talking about squares, look what's next. You know squares are showing up on your test. It's been on every test for the last 10 years, and I'm not stopping. So please get the quick points right away. You copy, you keep copying. Isopropyl, and oh man, I'm gonna pull a fast one. It's a dangerous fast one. No, it's a terrible fast one. I'm gonna draw this thing twice, but it won't let me grab it. It's okay, I'll be like a student and draw it twice. Okay, OH here for one. And the other carbon of the thing for 2. Do not circle, oh, it's not Cl, Dr. Whitaker. There's no HCl in this reaction. By the way, this is the hydration reaction. You'll have a hydration predict the product. And this is the hydrohalogenation. You will have a hydrohalogenation to pick the products. Those are our only 2 reactions. They're 2 separate questions. That's what that big line is. Yeah. Maybe I should move the hydrohalogenation over, huh? But then the hydration's with it. Oh, well.
HCl is just HCl, kind of like
HCl, HBr, or HI?
Yes.
Yes, and water with hot or sulfuric acid. Those are your 5 possible options for the 2 questions. Water with hot or sulfuric acid. Previous video, we said sulfuric acid does the same as water. Water does the same as sulfuric acid. No, I think it was this video. Truth. So this could be hot or sulfuric acid. It's hydration. This could be HCl, HBr, HI. Hydrohalogenation, every one of them. Now you got to talk to me about rearrangements. And if you're like me, don't even try a rearrangement question until you've drawn the cations. So I'm going to put them outside the box. They don't count for points. Your 2 cations that you initially get are just as easy as the products. Copy the skeleton. One of the cations is here. It is a candidate for rearrangement because adjacent, there are branched carbons. The other cation is also a candidate for rearrangement because it's adjacent to, adjacent to branched carbon. Your hydrogen shifts are as follows. Wow, I don't know what to do here. Now it's venturing inside the box. Both of them are ventured inside the box. Very dangerous. You're going to think they're worth points if I get them in the box. Yeah, that wasn't bad. Was it on the down or the up? Where's that double bind? Right there.
No, but the upward.
This one?
Other side.
This one? Oh yeah, where the double bind went. And this guy's got to move out of the box. That's a lot of moving. That one was there. Get it out of the box at all costs. Close. Sorry, very violent. There's your cations. I don't know how many rearrangements each one has. Oh, yes, I do. There's always 3 ways to rearrange those branched things. Nasty. Too many. Getting dizzy yet? Where was the cation at the top right? And I just need to One more of those. This is for your education, not really for points. The rearrangements go like this. I'd like to point out that this rearrangement is a waste of time. You are charged with telling me why. What's the result after you do that rearrangement? It's already on the screen is why it's a waste of time. It's this. That's the result. You're already predicting products from that result. So if you can get there directly, you're not going to waste your time and make a secondary and then rearrange to a tertiary. It's not happening. So get rid of that. That's one of the possible rearrangements is no good. It doesn't give you anything new. So let's not think about rearranging from the left. Let's talk about the top. Your possible bonds are this one to make a more stable tertiary cation. Okay? The methyl to make a secondary, which means it doesn't happen. Secondary doesn't go to secondary. Why? It didn't get more stable. And that's all you need to know. We could also talk about this breaking and going down there because that's adjacent. Once again, it's going to make another secondary. Doesn't happen. So we are going to do this one. The result is in green here. The result of the rearrangement is going to be temporarily here because it's going to be a cation. And cations are not final products. You're going to tell me how to fix it. There's the new cation. What do you get right after you get the cation? You get an oxonium ion when water attacks. See how I think like a mechanism thinker? Water's going to attack that and get an oxonium. That also is not your final product. Neutralize the oxonium to an alcohol. So what are you putting there instead of the cation? You've already done it twice. An alcohol. So cation is gone after it gets attacked by water. Apparently a lot of other stuff goes away if you use the big eraser. And you get an OH. And that's from rearrangement 1. Rearrangement 1. There you go. You don't have to write from rearrangement 1 on your test. I'm only going to grade your molecule. This is for you to learn. Okay, we've explored all 3 possible rearrangements for the 1 cation. Let's do the next cation. We didn't need another copy of this one. We're out of rearrangement options. The rearrangements I like the best, from a branched carbon 1 away from this, that's not branched. That's not branched. That's branched. Your choices are move the H, move the C this way. I didn't draw my isopropyl there, I know. Sorry about that. Then move the C that way. All 3 of these give new cations that are more stable or equally stable. This is already tertiary, right?
Yeah.
It's going to put a plus charge on the cyclobutane. That's awful. Wasn't that the worst place? Isn't that the worst place? Can you tell me why putting a plus charge on the cyclobutane is just awful? It suffers greatly from 2 types of strain, angle and torsional. So I'm going to tell you something. If you give me the product where the OH is, instead of the H here, you got an OH, I'm going to give you a point for it. I'm not going to put it on this test because I know it really doesn't happen. But you are showing me you know when rearrangements are allowed and what they look like when it's done. So you deserve a point for that. Okay? I'm not going to put a point for it. But the other 2, get rid of that terrible strain, right? Ring is getting bigger. Ring is getting bigger. It's time for our labels A, B, C, D, E. Baby blue. No, it's too faint. Boulder blue. I like going A, B, C, D. There's no right or wrong way to do this labeling, okay? Same labeling. So green, wow. I need to see the rearrangements and then draw the results. We're sticking with green, rearrangement 3, and I'm going to go straight to the product this time. Rearrangement 4, I'm going straight to the product. So we copy the 5, and then the bond from here, and then the bond to B, C, D, and then the bond to isopropyl. And now labels say E, A, B, C. You tell me where the new bond is that you moved. 2 letters, please. New bond between who and who? Based on this arrow. A and E are already bonded, and I didn't do anything with the bond. The bond is there, I didn't touch it. D is now bonded to E, A lost a bond. So 2 things need to be put on. The new bond, D to E, and where the cation is, the atom that lost the bond. Which one is it? A. Don't put a cation there. What goes where the cation was? Okay, it is a cation. She told me what a cation was. I think she also knows at the end, what did we put at the end every time? OH. Doesn't stop now. Okay, that is rearrangement 3, giving this result. Rearrangement 4, carefully copying ring size 5 with a method. A to E still there. It's A to D still there, to C there, the B not there, B still there, but isopropyl still there. Where's the new bond? You want labels? You want the labels. E, and that was A, and that was B. I broke the BA bond. Where's the new bond? BE. So A, cation again, but we don't put a cation there. This is a final product. What do we put there? OH. And that was rearrangement 4. My computer is having a bit of a thing. Okay. There we have it. Didn't ask for any explanation. Good news. Okay.
Those are all possible.
Yeah. And